Problem solving with quadratics. Objective. By the end of this lesson, you should be able to problem solve using quadratics. So some real world problems can be solved using quadratic equations, but anytime we get an answer, we want to make sure our answer is reasonable. So what does that mean? Well, if we're trying to solve the length of a side, well then you can't have any negative answer, right? Because the length can't be negative. It's just like they ask you how many people are present. You can't have a negative answer. And generally, just want to make sure that your answer makes sense in the context of the problem. Sometimes your answer is too big, sometimes it's too small, sometimes it's a decimal and it can't be a decimal. You just gotta think logically when you look at your answers. A general solving method we use when we solve quadratic problems is, well, first we translate into algebra. So usually it's like a word problem or a application problem. We want to translate to algebra, where x represents the thing we're looking for. Make sure your units are appropriate. We solve by whatever method we could solve. And then we look at our answers, make sure they're acceptable. And then usually you get an answer in a sentence. So that's generally the process. You read the question a couple of times, put in algebra terms, solve it, check your work, and then write a sentence. So let's look at our first one. A rectangle is a length of 3 centimeters longer than its width, and its area is 42 centimeters squared. Find the width of the rectangle. So they want to find the width. I like to draw pictures most of the time if I have a chance. So we have a rectangle. Has a length 3 centimeters longer than its width. So what I generally do is I do whatever the smaller thing and make that my x. So here I have a length and a width, and the length is longer, so my width is x. Length, width really doesn't matter, but I'll make one of these x. And then the other one is 3 centimeters longer, so x plus 3. I could erase the w and the l. There we go. So this is my width, this is my length. Its area is 42. So then you gotta think, okay, how do I find area of a rectangle? Well, it's length times width. So in this case, it's gonna be x plus 3 times x equals 42. And all we gotta do is solve this. So do some algebra. Let's distribute x squared plus 3x equals 42. We have a quadratic equation, so we're going to set equal to 0 and factor, or use a quadratic formula. So subtract 42 from both sides. X squared plus 3x minus 42 equals. Now, does this factor? Two things that multiply get negative 42, but add to get 3. 6 and 7 are closest, though. No, I don't think it factors. So if we can't factor, we have to use a quadratic formula. A, B, C, x equals negative b plus or minus square root of bc minus 4ac, b squared minus 4ac all over 2a. So we get x equals negative 3 plus or minus 3 squared minus 4 times 1 times negative 42. Great. All over 2 times 1. This is 9 minus 168 plus 168, two negatives. So x equals negative 3 plus or minus 177 over 2. Now it's an application problem, so you are allowed to use a calculator to get a decimal, because that's what we want. I'll put in my calculator off camera, and we get x is approximately negative 8.15 or 5.15. Now again, this is a side length, so it's the length of a side. I can't have a negative length of a side, so my answer is just going to be this. So I say the width of the rectangle with an area of whatever is 5.512 centimeters. So there we go. Next one. The product of two consecutive odd numbers, is 225. Find the numbers. Okay, so two consecutive odd numbers. Anytime you want to find consecutive odd or even numbers, it always goes the same way. It's x and x plus 2. Because think about it. If you had 2, what's the next even number? 4. You add 2 to get. If you have 3, the next odd number will be plus 2. So anytime you want consecutive even or odd numbers, it's this way we set it up. Those are consecutive odd numbers. If you just want consecutive numbers, you go x plus 1. Because that's how you get consecutive numbers. So two consecutive odd numbers, though, or even, it's just x and x plus 2. And then their product is 225. So when I multiply these two guys, I should get 225. So we get that. Now we just got to solve it. Distribute x squared plus 2x equals 225. Subtract 225 from both sides. Equals 0. Again, I have a calculator. I can use quadratic formula again, or if it factors, but I don't think it factors. So off camera, I did type it in, and it does not factor, which means it's not an integer, which means you can't solve, because consecutive numbers or odd numbers have to be integers, so there's like no solution to this. No solution because not integers. I could do a negative if I want, but you actually don't get. So that was kind of weird. Yeah, sorry about that one. Is it possible to bend a 12 centimeter length of wire to form the perpendicular sides of a right angle triangle with an area of 20? Okay, so this one's a little weird. So we have this wire that we think is 12 centimeters. I want to bend it at some point. So I'm going to bend it at some point to make a right angle with the area of 20. So let's say I bend it right here. That means I'm going to get something that looks like this. And I'm going to get something that looks like that. Alright, so it's bent right there. This is my purple. So it's also going to wire length to form the perpendicular sides of a right angle triangle with area of 20. So these are the sides of a right angle triangle. And they're saying, hey, this is my right angle triangle. I want the area of that thing to be 20 centimeters squared. And the trick to doing this, well, we know the whole length here is 12, so we're just going to label one side x. And that makes the other side 12 minus x. So x and 12 minus x. So now the sides of my triangle, I know the area of the triangle is this. And the same formula connects it all. Well, area of a triangle equals 1/2 base times height. So I'm going to get 20 equals 1/2 base, which is 12 minus x, times the height, which is x. So it's going to be a little ugly. I'll multiply these in first. So 1/2 12x minus x squared. Now I don't want to deal with fractions, so instead of multiplying out the 1/2, I'm going to multiply both sides by 2. So I'm going to deal with fractions. So I get this. And now we want to solve this quadratic. So easiest way to do it, set equal to 0. I don't like having negative x squared, so I'll move this over. And move the 12 over. So I'm going to have x squared minus 12x plus 40 equals 0. Now let's see, if this factor, I need two things that multiply to get 40, but add to get negative 12. Not 4 and 10, not 5 and 8. So no, I think it's prime again. Great. So quadratic formula. So x equals negative 12 plus or minus, oops, positive 12 actually. Negative 12 squared minus 4 times 1 times 40 all over 2 times 1. This is 144 minus 160, and look what's happening there. I get 12 plus or minus negative 16 over 2. Now I normally would simplify all that stuff, but I don't need to. This is an imaginary number, so it's not possible. Now remember, that's a discriminant. Like the value underneath the radical is always a discriminant. That's the form for discriminant also. So they're the same thing. And this is less than 0. There's no point of intersection, so it's not possible. So this situation is not possible. And there we go.